Okay, so this is a grid that I made up to solve that fourth Olympiad problem. This is a really cool problem. When I first started trying to solve this, I went like way down the rabbit hole, and I had a really bad solution. Didn't work very well. But then I went back and I think about it, and I realized, oh, there's actually a much easier way to solve this. And how I did it is I made a table. Now, those of you that have known me for a long time know that I love tables. They are my best friends. Tables. They're so useful. And this applies here as well. So what is this table doing? Well, Okay, so how this grid that I've made works is that these numbers here each represent the place values of the adding number. And remember the rule that an adding number is created when the first and second digit add up to the third, and then the second and third add up to the fourth, and then the third and fourth add up to the fifth. And then the Olympiad is asking you that famous Olympiad question, which is, how many are there? And whenever the Olympiad is asking you a question like this, they are probably wanting you to, what they're doing is they're asking the question, which is, are you someone who can work systematically? Systematically is a big word, but what it really means is, are you someone who can work step by step? So do you go in sequence and follow a series of like logical ideas? This is supposed to be a light bulb, ding, when you're working, or are you someone who's like ding, 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 working all over the shop? Okay, now someone who works all over the shop actually can be quite creative, especially in mathematics, but not all problems are created equal, and this kind of problem is one that really asks you to work systematically. So let's see how to solve this. How many are there? Well, where should we start? We should start at 0. Let's just start at 0. Let's make an adding number with a 0 in the leftmost digit. So I put a 0 here. And, well, I guess I can't repeat any digits. It's one of the rules, is no repeated digits. No repeated digits. So that next smallest number is 1. And then the rule says that the third number is the sum of the first two. So 0 plus 1 is 1. Uh-oh, now I've run into a problem. There can be no adding number that begins with 0. Why? Because I've just repeated digits, 1 and 1, and the rule says I can have no repeated digits. So let's work systematically, and try the next biggest number. Don't just jump around, try the next biggest. Well, the next biggest number would be 1. And then the next one after that would be, well, actually, it would be 2, but maybe I wasn't sure about the 0 theory, so I try 0 again. And of course, 3, the third digit, is the sum of the first two, which is again 1. So although those are different numbers, that also is not an adding number, so that won't work. Okay, hopefully we've gotten that out of our system. Let's try a real adding number this time. A 1, start small, then a 2, that's the next smallest. 1 plus 2 is 3. 2 plus 3 is 5. And 5 plus 3 is 8. Now, we have no repeated digits, so there you go. We have our, our first adding number. Yay. Okay, well, how would we work systematically to find another adding number? Well, I haven't exhausted all the potential possibilities with a 1 here, so let's just put another 1 there. And instead of a 2 in this place value, I'll put the next smallest number, put 3. Okay, 1 plus 3 is 4. 3 plus 4 is 7. Oh, hi, Grizzly. Oh, hi. My doggies come to say hello. Hello. Where was I? Oh, yeah. 1 plus 3 is 4. 3 plus 4 is 7. 4 plus 7 is 11. And, uh-oh, no adding number. Why is that not an adding number? Well, 11 is not a digit. It's a number with 2 digits in it. So we might have to think a little bit more carefully about how we continue. Clearly, if 3 doesn't work here, 4 will also not work, because that's just going to make this sequence explode even quicker. It's going to get bigger even faster. So what I need to do is start with, a 2 in the front. So what about 2 and a 1? That gives me a 3. Then 1 and 3 is 4. And then 3 and 4 is 7. 4, 5, yeah. Good. That's an addy number. There's 2 of them. Yay. Let's see. Can I continue in this fashion? Could I do like, maybe I could do 2 and 3 is 5. Then 3 and 5 is 8. Uh-oh. See what happened? I got to 13. And 13 is not a digit, it's a number, so that doesn't work. Okay. What else could I do here? Let's have a think. Well, maybe I could move to one more digit up. So how about I try a 3? 3 and a 1, which is 4. 1 and 4 is 5. 5 and 4 is 9. Okay, there we go. We have our third addy number. Can I go higher? Well, the only way to do this, and I guess the next logical step going to be systematic here, would be 3 and 2, which gives me 5. 5 and 2 is 7, and boom, straight away I got myself up to 12. 12 is not a digit. Anything beyond this, okay, is going to get too big. Okay, anything below it is not allowed because zeros produce repeated digits. Okay, so the problem space that we're looking at is pretty small, actually, which I love about this question. Originally, you read it and you think, oh my gosh, I'm going to have to do hundreds of these. Well, you don't. You just have to test basically 5 or 6 of them. And the answer, of course, is 3. There are 3 addy numbers. It's a hilarious 3. Let's see. Anyways. Okay, hopefully that all made sense. Good job, guys.